Hello and welcome. In the lecture series on the elements of machine design, myself Mr. S.S. Mari, HOD Mechanical Engineering Department, Chair Institute of Technology Polytechnic, Etro. In first lecture, we have seen the introduction regarding the syllabus of elements of machine design. Now, in lecture number 2, we will see the fundamentals of machine design. That is, what is meant by the machine design? What are the basic principles involved in the machine design and the basic general considerations in the design of a machine component. So let's start with the definition of a machine design. So before going into the machine design, let's have a look on what is meant by the machine. As we know that a machine is a device which receives energy in some available form. That is, it receives the energy in the form of some input and utilize this energy to do a particular task, that is work. That is the main purpose of the machine, to perform a particular task by utilizing some input energy in form of any form of energy. It may be electricity energy, it may be mechanical energy, it may be solar energy. In any form, it receives energy and it performs tasks. Or we can again define a machine. It is a mechanical structure that uses power or energy to apply forces, and by applying these forces, it controls the movement to perform a particular task. This is known as the machine. There are different examples of the machine in day-to-day life that we have seen. How the task is performed by the machine. By taking some kind of a input energy, it performs some tasks and it gives a desired output which is intended. So this is a simple definition of the machine, what we can say a machine. Now just move towards the machine design. What is meant by the machine design? A machine design, actually this subject or this course is concerned with the creation of new and better machines. Now as we know that there are different types of the machines are existing in nature, but due to some limitations of that machines, due to some limitations of the task which is performed by that machines, we need to go for the better machines, better devices. So the basic task or basic aim of machine design is to create a new and better devices from the improved or existing ones. That is the major fundamental basics of the machine design. A new or better machine is one which is more economical in the overall cost of production and operation. That is the main aim. When we are going for the creation of a new machine or device, the basic aim is that it should be economical in the overall cost of production and operation. So we can form a different definitions of the machine design, but in a simple language, we can define a machine design in such a way that it uses the scientific principles, technical information which is existing, and the imagination of an engineer in the description of a machine or a mechanical system. So before actually designing of any component, the basic aim or basic idea starts with its imagination and the available technical information, and the intention for it is going to be design. For this, it uses some scientific principles to perform a specific function with maximum economy and efficiency. That is the most important, to perform a specific function with a maximum economy and efficiency. So in a simple language, we can define a machine design that it uses the scientific principles, existing technical information, and imagination of an engineer in the description of a machine or mechanical system to perform a specific function with maximum economy and efficiency. Now the machine design is a long-term process. The process of design is a long and time-consuming one. From the study of existing ideas, a new idea has to be convinced. That means the idea is studied keeping in mind its commercial success, and then studied to give and form in the form of drawings. In the preparation of these drawings, care must be taken of the availability of the resources money, man and materials, which is required for the successful completion of new idea into actually reality. This is the basic requirement of a machine design. So in simple language we can define a machine design is the art or is the use of scientific principles, technical information and imagination in the description of the machine or mechanical systems to perform a specific function with maximum economy and efficiency. So this is regarding the machine design. Now just move towards the some important features of the machine design. Before going to design a particular component of a particular machine, what are the basic important features? A designer uses principles of basic engineering sciences. Now, before going into the design of a machine or mechanical system, the designer uses principle of basic and engineering sciences, that is the physics, mathematics, statics and dynamics, thermodynamics, heat transfer, vibration and fluid mechanics. These are the some of the basic engineering principles that is used while performing the task of design of a machine component. Now second feature is the designer has the technical information of the basic element of a machine as we have defined in the definition. These elements include the fastening devices, that is a chain, fastening devices, that is nut, bolts, chains, this is power transmission elements, chain, belt, gear drives, bearings, oil seals and gaskets, springs, shafts, keys, couplings. Now through these all elements we are designing a machine component, that is the basic elements of the machine component. Now third feature that taken into account is the designer uses his skill and imagination, as we have already defined what is meant by machine design, that it uses the scientific principle. These are the scientific principles. Then technical information, the basic technical information that is available with the designer, and its skill and imagination to produce a configuration or a mechanical system which is the combination of the different basic elements. That is the machine, that is the designing of a machine, that is the designing of the mechanical system, that is the designing of a mechanical component to perform intended function. And the final outcome of this design process is the description of the machine, how this machine will perform its specific task. That is the description of that machine. That is the final outcome of a machine design. That is the description of the machine. Now the description is in the form of drawings of assembly or individual component. Now description of the machine is nothing but its dimensions, its different processes that is to be carried out, and its applied loads, stresses induced in that component, individual component, or drawings of the components. So this is the final outcome of that machine component, and the design is created to satisfy a recognition need of the customer. That is the main aim. We have to design a particular machine to satisfy a recognized need of customer. That is the most important. We are not going to design a machine in a vague nature. There is a one output, there is one criteria, there is one recognition of a need of a customer, and by keeping into mind this recognized need of a customer, we are going to design a machine component. So the need may be to perform a specific function with maximum economy and efficiency. That is the most important. The machine or machine component or mechanical system that we are going to be designed, it should perform its specific function with a maximum economy and efficiency. That is the output of the any machine design. But this is the most important feature of the machine design. So these are the some basic features, that is the use of scientific principles, use of basic technical information, use of skill and imagination of the designer, description of the machine final output, and the intended need, that is the recognition need of the customer. That is the basic features of the machine design. Now after understanding the concept of machine, After understanding the concept of machine design and the silent features, now let's move towards the classification of machine design. How this machine design is classified. Now this is the basic classification of the machine design, how the machine design is classified. Now first is the adaptive design. Now what is meant by the adaptive design? Adaptation. Adaptation means to concern with the new things. That is the adaptation. In most of the cases, the design work is concerned with the adaptation of existing designs. Now already some components are designed, already that machine part is designed, already that mechanical system is designed, but due to some limitations of that element or the basic information of that element, the designer is going to be design or make some changes, alternations in the existing one. That is, this type of a design needs no special knowledge or skill and can be attended by the designer for ordinary technical training. The designer only makes a minor alternation or modifications in the existing design of the product. Now these modifications or alternations are made to overcome the limitations of the existing design. That is the adaptive design. In simple language, we can say adaptive design is the modification of existing design to overcome its limitations, to improve its efficiency, to improve its economy, to give a desired output. That is the adaptive design. That is the modification of the existing one. That is the adaptive design. Now next type of a design is the development design. Now in this case, the design engineer develops a machine component or mechanical system which is not existing one, but it modifies the existing design into a new idea. In adaptive design, design engineer just modify the existing design in itself only. But in case of a development design, and design engineer take the help of the existing designs, and by taking the help of the existing designs, existing design criteria, uses its scientific training and design ability and prepare a new idea by adapting a new materials or different methods of manufacture. In this case, though the designer starts from the existing design, but the final product may differ quite markedly from the original product. Now, in case of an adaptive design, the product is not new. The product is, that is the old product. There is just modifications in the older product, existing product. But in case of the development design, a remarkable modifications has been done in the existing one, and a new product comes into the market. New machine structure comes into the existence. New mechanical system comes into existence. That is the development of design. That is the development design. And the third one is the new design. Now, in case of adaptive design or development design, we are making use of existing principles, we are making use of existing ideas, we are making use of existing machine structures, we are making use of existing design. But in case of new design, this is totally new one, which require research, technical ability and creative thinking. So there is no use of the existing design. It is just a creation of new idea. Though it is using a scientific principles, but it is a creation of a new idea. New machine component, new member, new drawings by looking into the customer needs. That is the new design, which requires a research, technical ability and creative thinking. So this is the basic classification of the machine design. There is the adaptive design, which adapts, make use of existing one just to make small modifications in existing. It is created. In development design, a new product is developed by taking help of the existing design, and in new design, without taking the help of existing one, a new research has been carried out, new thinking has been developed, and new product is coming to the market. Machine structure has been manufactured. That is the design. That is the new design. So this is regarding the classification of the design. Now there are another method of the design also there, depending upon the methods, that is the rational design, empirical design, industrial design, system design, element design, or computer aided design. These are the basic classifications of the machine design. Now after understanding the concept of classification of machine design, now just move towards the general considerations in the machine design. Now this is the most important part. Considerations in the machine design. Considerations in the machine design means the factors that we need to consider while designing a machine component. Now before designing any machine component, these are the some factors that need to be considered by a design engineer while designing any particular component. Let's see one by one what are the considerations in the machine design. The first consideration, first factor that need to be considered into account, that is the type of load and stresses caused by that load. We know that when a machine component comes into the practice, or when a machine component is subjected to the application, a particular application, a different types of the loads acting on that machine component, and due to the application of these different types of the loads, there is a induction of the stresses in the machine component. That loads and that stresses are need to be considered while designing of that component. This is the basic criteria. We need to consider the type of the stresses induced in that component, and by considering the type of stress which is induced in that component, we need to design that component by taking into account that stress as the criteria for that design. Suppose we apply the tensile load on a component, then due to the application of tensile load, there is an induction of the tensile stress in the component, and when that component will fail due to the tensile stress, then we have to design that component by considering a tensile stress as the criteria of the design. That's why we have to consider the type of load and stresses which are caused by that load while designing a particular component. That is the basic design consideration, that is the type of load and stresses induced in the component. Now next is the motion of the parts, that is the kinematics of the machine. We know that the successful operation of any machine depends largely upon the simplest arrangement of the parts, which will give the desired motion required. We know that machine moves, machine components moves, there is a motion of the parts, there is a movement of the parts, and that movement of the part, that is the motions of the part or motions of the element, should be simple one. That is the basic design consideration, that motion of the part should be simple, it should not be complicated. The machine should move, or the different elements of the machine should move in an easy way. So if you take the examples of the motions, we know that there are different types of the motions. Rectilinear motion, which includes unidirectional and reciprocating motions. Curvilinear motions, which includes rotary, oscillatory and simple harmonic. Constant velocity, motion with constant velocity. Motion with constant or variable acceleration. So these are the different types of the motions which are imparted during the movement of the, during the working of the device or machine. So these are the motions, that type of the motion need to be considered. Now third part is the selection of material. Most important part, the selection of the material. It is essential that a designer should have a thorough knowledge of the properties of the material and their behavior under working conditions, because many times a machine component will undergo a different working conditions. That is, some of the important characteristic of the material that we need take into account while designing of machine components are, that is the different properties of the material. A design engineer should have a knowledge of different properties of the material which is selected for a mechanism, particular mechanism, or for particular element. The different properties that need to be taken into account are strength, its durability, its flexibility, its resistance to heat and corrosion, because many times the machine elements are subjected to different types of the heat treatment processes, different types of the environments where it can be corroded. So it should have a resistance to the corrosion, welded or hardened, its machinability, its electrical conductivity. So these are some of the properties that taken into account while selecting a particular material for a particular component. This is the third criteria, that is the selection of the material. Now fourth considerations in the machine design are form and size of the parts. Now form and size of the parts based on its judgment, because the smallest practicable cross section may be used. In order to design any machine part or form and size, it is necessary to know the forces which the part must sustain, because when we are using the parts or size of the parts, it is preferable that we should use a smallest cross section whenever it is possible. Now in order to design any machine part for form and size, it is necessary to know the forces which are acting on that component, and it is also important to anticipate any suddenly applied or impact load which may cause failure. So to taken into account these factors, the form and size of the part is also one of the essential parameter that taken into account. Okay, so next consideration is the frictional resistance and lubrication. As we all know that when two rotary parts or stationary and rotary parts come into contact, there is a friction between their two parts, and there is a loss of the power due to this friction. So to avoid the loss of the power, we need to take into account how we can reduce this frictional resistance, and this frictional resistance can be reduced by a proper lubrication. So a lubrication of all surfaces which move in contact with others is necessary. That means the design engineer should consider the frictional resistance that is happening, that take into account when that component will be subjected to the application. So frictional resistance and lubrication need to be considered before designing, or how we can carry out that lubrication, or how we can decrease that frictional resistance. Now next consideration is the convenient and economical features. Now what is meant by the convenient and economical features? Now economical operations, the operations of a machine which is to be used for a production or for the processing of a material should be studied in order to learn whether it has the maximum capacity consistent with the production of a good work. Now in case of conventional and economical features, the adjustment of wear must be provided employing the various take-up devices and arranging them so that the alignment of part is preserved. If parts are to be changed for different products or replaced on account of wear or breakage, easy access should be provided, and the necessity of removing other parts to accomplish this should be avoided if possible. That means there should not be replacement of the parts, usual replacement of the parts. The replacement of the parts should be avoided, and the starting, controlling and stopping levers should be located on the basis of conventional handling. When you are designing a machine, now take the example of the lathe machine. When we are designing a lathe machine, the components of the lathe machine, then the design engineer should consider the starting point, its stopping point, and the position of chuck, position of headstock. This part needs to be taken into account, because there should be an easy handling of these parts, that operators should easily start and stop the machine. There should not be any extra effort required to start and stop the machine. That is the convenient and economical features of that machine. The next part is the use of standard parts. Use of standard parts. The use of standard part is closely related to cost, because the cost of standard or stock out part is only a fraction of the cost of similar parts to be ordered. Take an example. That means when you are going to design a particular machine or machine component, it is necessary to use a standard parts which are available in the market for the assembling of a particular machine component. Every time it is not feasible to design each and every part of that machine. If a standard shaft diameter is available in the market, then you can go for the shaft having that standard diameter. It is not necessary to design that shaft to manufacture that stuff to have machining processes. If a standard nut and bolts are available, if the standard dimensions of the different assembling components are available, then it is feasible to go for the standard components rather than making that component in your workshop. The standard or stock out parts should be used whenever possible, for which patterns are already in existing, such as gears, pulleys, bearings, and parts which may be selected from regular shop stocks such as screws, nuts, and pins. So no, these are the standard parts. It is not necessary that you should go for the designing of these parts. It will add the cost into the, it will add to the cost of the machine component. So it is necessary to make use of the standard parts as possible as. Next part is the safety of operation. Now, while designing of any machine component or while designing of any machine, and design engineer should always provide safety devices for the safety of the operator. The safety appliances should in no way interfere with the operation of the machine. It is most important when an operator going to operate that machine. The safety considerations are very important. Or when we are using any machine or any device, the safety considerations are very important. It is therefore necessary that a design engineer should always provide to the safety devices for the safety of the operator. Some machines are dangerous to operate. Take the example, especially those which are speeded up to ensure production at a maximum rate. Sometimes it is necessary to improve the speed or feed rate. At that time, when any moving part of the machine which is within the zone of a worker is considered an accidental hazard and may be the cause of an injury. So it is therefore necessary as a design engineer that it should take into consideration that there should not be any kind of accident which will cause due to the operation of a machine component. That's why while designing a machine, the design engineer should take into account the safety of the operator. The next consideration is the workshop facilities. Now, as a design engineer, he should be familiar with the limitations of this employee's workshop in order to avoid the necessity of having work done in some other workshop. That means if a design engineer is making some parts, so sometimes it is necessary to plan and supervise the workshop operations and to draft methods for the casting, handling and machining of special parts. Sometimes design engineer go for the design of a machine component, and when we are designing that machine component or machine, some of the parts require some special operations. But at that time, if that facilities are not available in that workshop, then it will add to the time consuming process. It will add to the cost. So it is necessary to plan the pre-planned activities, that which operations we have to perform, which operations are required by the machine component, that should be taken into account by a design engineer before actually going into the design procedure. Next consideration is the number of machines to be manufactured. The number of articles or machines to be manufactured affect the design in number of ways. How? The engineering and shop cost, which are called as the fixed charges or overhead expenses, are distributed over the number of articles to be manufactured. The final cost of the product will be decided by considering these all things. That is the fixed charges, overhead expenses. If only a few articles are to be made, suppose if requirement is a few articles, a few machine parts to be made, now extra expenses are not justified unless the machine is large or of some special design. And order calling for a small number of product will not permit any undue expense in the workshop processes, so that the designer should restrict his specifications to the standard parts as much as possible. That's why that is the use of standard parts. If you are not going to use the standard parts, then it will add to the cost. And if the order is for fewer parts, and if a special machine is required to carry out that machining processes for that machine component, then it will add to the cost of the product. That's why it is necessary to decide the number of machines to be manufactured, number of machine components to be manufactured before actually going into the design procedure. Next is the cost of construction. Now, in case of a cost of construction is the most important consideration in the design. In some cases, it is quite possible that the high cost of an article may immediately bar it from the further consideration. If an article has been invented and tests of handmade samples have shown that it has commercial value. Now, the aim of the design engineer in all conditions should be to reduce the manufacturing cost to the minimum. That is the most important consideration, that the aim of the design engineer under all conditions should be reduce the manufacturing cost to the minimum, because that will add to the cost of the machine, that will add to the profit of the organization. That's why as an engineer we all should aim to reduce the manufacturing cost to the minimum. To have this kind of the consideration, or to fulfill this consideration, the above all considerations are important, taken into account to have this fulfillment of these considerations. Unless and until we will not take into account these above all considerations, we are not going to fulfill these considerations. That is the cost of the construction or cost of the machine. That is, it is then possible to justify the expenditure of a considerable sum of money. The aim of design engineer should to reduce the cost of the machine. And the last consideration is the assembly. Now, every machine or structure must be assembled as a unit before it can be function. We know that after manufacturing, after designing all the components, all the components are assembled to form a particular machine. Now, every machine or structure must be assembled as a unit before it can be function. Large unit must often be assembled in the shop, tested, and then taken to the transported to their places of service. The final location of any machine is important, and the design engineer must anticipate the exact location and the local facilities for erection. That is most important. If you are assembling a particular machine or device at a particular location, and if that requirement of that machine or that assembly at the farthest distance, and if there is no transportation facilities available, then again it will add to the cost of the machine element. That's why design engineer should take into account where we have to assemble the component and where is the erection of that assembly. So these are the some basic factors, design considerations that need to be taken. Just have a look. There is the type of load and stresses. Second, motion of the parts. Third, selection of materials. Fourth, form and size of the parts. Fifth, frictional resistance and lubrication. Sixth, convenient and economical features. Seventh, use of standard parts. Next, safety of operation, workshop facilities, number of machines to be manufactured, cost of construction, in cost of assembling. So this is regarding the introduction to machine, introduction to machine design, classification of machine designs, principle of machine design, and considerations of a machine design. I hope you have understood the concept of these considerations. In next lecture we will see the design procedure. Thank you.